Welcome to day 3 of this summer tutorial class. Please make sure you pay attention to everything we are doing here. Have your notes right down. Today we are going to look at another important topic that you will always see in your JAMB, WAEC. For those in undergraduate class, we are making progress. You will also see things like this in Physics 101. Please pay attention to today's class and always do the assignment given at the end of each video. Go to the community question section. All the assignments are there and vote for your own answer. Thank you so much. Let's move right into the video. The weight of a body in a lift. I'm going to open your eyes today to something that will help you solve problems like this.
Welcome to today's class.
Okay, let's have this to be an elevator. Let's say we have a man inside a lift or an elevator. 2 forces are acting on this body. The first one is the weight, which is equal to mg, acting downward. Just know that the weight always acts down. And then we have another force, R. That's the reaction force from the floor of the lift acting towards the man, that's R. Now we are going to have case 1, case 2, and case 3. 3 major cases for a man standing in a lift or elevator. The first case we are going to look at, case 1. Let's look at case 1. Let's call this one case 1. Case 1 is when the lift is stationary or moving with a constant velocity. Remember that once velocity is constant, once you have velocity to be constant, it means that acceleration is 0. Once velocity is constant, acceleration is 0. For this particular one, we are going to have it that the weight is equal to the reaction force because the man is not moving, it's balanced, everything is stationary. Now let's look at case 2. For case 2, if we have it that the lift is accelerating up and the man is moving up, that's why I'm using this arrow to indicate acceleration is up. What are we going to do? The resultant force F is going to be equal to, remember, is moving up. So we have R is the one pulling, let's say more, is moving in the direction of R. R plus mg. Why am I putting mg? But this time around I will have minus mg. Why am I using minus mg? Because we are using acceleration due to gravity for this. And acceleration due to gravity draws every object downwards. But this time around, the acceleration is up. The man is moving up. So here is minus mg. So that remember, this F is equal to ma is equal to R minus mg. So the reaction we are going to get, R is ma plus mg. That's this one crossing to the other side. So whenever the lift is moving up, you're going to use this formula. You can factor it out as m into a plus g. Note it. This is when the lift is moving up. You use that formula to solve it. Now let's look at case 3. Remember, reaction is up and the weight is down. For case 3, if acceleration, the lift is going down, accelerating downwards, the man is moving down, maybe let's say moving from the 5th floor to the ground floor, acceleration, the lift is going down. At this point, the resultant force is going to be, remember, this is moving in the direction of, which means that mg is pulling it. Therefore, the resultant force is going to be mg minus r. This is more, it came first. Remember, when it's moving up, this r came first. Now it's moving down, this is coming first. F is ma is equal to mg minus r. R can move to this side so that r will be mg, this is moving to the other side, minus ma. So whenever you have it that I factored out m, whenever you have it that the lift is accelerating downwards, we are going to have it to be m into g minus a. Now the final case we are going to look at is, what if the lift falls freely? For instance, if the cable is cut, if it falls freely, for free fall, the acceleration will be equal to the acceleration due to gravity. Hence, the case of weightlessness. So when it falls freely, acceleration A will be equal to G. Let's take calculation example. A load of mass 80 kg is placed in a lift. Calculate the reaction between the floor of the lift and the load when the lift moves upwards, I at constant velocity, I with an acceleration of 2 meter per second square. Take g to be 9.8 meter per second. So let's write out everything we are giving. We are giving that m is 80 kg, that's the mass. G as 9.8 meter per second square and A as 2 meter per second square. Okay, we are looking for the first one. The first one at constant velocity. Remember, at constant velocity, I said it before, once v is constant, acceleration is 0. And remember that the lift moves upwards. Okay, since it's moving up, when the lift move up, we have this formula, F is equal to R minus mg. Hope you remember, R first followed by mg. And this gave us the formula that the reaction force we are looking for, remember this formula that we were able to derive, is A plus G. Hope you remember this formula that we derived when the lift moves upward. So let's substitute to get the reaction force. That will be M. Remember, A is 0 plus 9.8. So we'll have our R to be 80. This one will give us 9.8. The reaction force will be 80 times 9.8. And that will give us 784 Newton. Then I, we are looking for when A is giving us 2 meter per second. When A is 2 meter per second square, we'll still use the same formula that reaction is M into A plus G. M is 80, A is 2, G is 9.8. So that we'll have 80 times 11.8, and that will give us the final answer as 944 Newton. Thank you for watching this video to this point. Please try the question, the assignment, and vote for your answer in the community section. Hope you enjoyed the class. Please do well to like this video, share it, and subscribe to this channel. Thank you.